Okay, so you're welcome to the STAT112 class. So the um, the course is being done under the Department of Statistics. Department of Statistics is under the School of Physical and Mathematical Sciences, and also part of the College of Basic and Applied Sciences. Right. Okay. Applied Sciences. Now, so the students taking these courses are those doing statistics, those doing actuarial science, mathematical sciences. We have some from College of Health and some from College of Humanities as well. So not only BSc students, but other students are part of it. So the course code is 112 and it is Introduction to Statistics and Probability 2. So STAT 111 was the Introduction to Probability and Statistics and Probability 1, right? Okay. So it's 3 credits, which means that we're going to meet 3 hours in a week. Okay. So the prerequisites for this course are STAT 111, which we just completed, Mass 121, and also Mass 122. So part of the things we'll be doing here, you will need your your calculus from Mass 122 to be able to understand it better. But I mean, if you've done elective maths at the SHS level and you've seen differentiation, integration, and so forth, you should be fine with this. Okay. Now, so delivery mode, we are going to meet face to face 2 hours per week. There will also be online resources on your Sakai. There's also 1 hour weekly tutorial. Okay. So the 1 hour tutorial usually will start maybe from the 3rd, 4th week when we have covered enough per each group, and then you'll be in a position to you'll be in a position to do some tutorials and so forth. All right. So academic year 2025-2026, second semester. The course facilitators, we have each lecturer is responsible for one group, right? Okay, and we'll be teaching for the whole 12 weeks, right? However, Dr. Deborah has 2 groups, so if you choose that group, you should always have stick to the group, whether group 1 or group 2 that you chose with. So my name is Professor Richard Minka, and I'll be the coordinator for the course. So my group is made up of the actuarial science student, and we meet Monday 7:30 to 9:30, Tuesday 7:30 to 8:30, 8:30 or 8:20. My teaching assistants are, as shown over there, Maminyako and then Gershon. The second group is Dr. Luchi's group, who meet at the same time, okay, as my group. You are free to join any of them, okay, and please join as early as possible so that you don't the group that maybe will suit you doesn't get full. Okay. Then there's Dr. Winnie group. They also meet Mondays and Thursdays. The teaching assistants are also there. Dr. Edward Champong also there. Group 4, Group 5, Group 5. Okay, so Group 4, the meeting times are also there. Dr. Champo. Group 5 will be Dr. Kala Dagadu. Group 6, Dr. Denisaku. Group 7, Dr. Benedict Mbia Baden. Then Dr. Gordon Deborah is taking 2 classes. So we have the Monday 9:30 to 11:30. They will meet for tutorials 1:30 to 14:20. So if you take that group, then it means you must go for that class, okay, 9:30 to 11:30, and then on Fridays 13:30 to 14:30. Now for the others, the other group, they will meet 3:30 to 4:30. Let me make it 13:30 to 14:30, and then this one will still be 13:30, 15:30. Okay. Yeah. So the tutorial, and then you have the main class on Friday. So please, if you choose any of this, make sure that you adhere to the class times for Gordon Deborah. Okay. And so there is a welcome message to the class. Okay, and basically this is mainly elementary probability. Remember, in the first one we talked about the statistics in the STAT112. So in 112 we focus on the probability part. So basically it will be elementary probability. So it's a foundational course that is going to give you the tools you need for what? Modern science, engineering, economics, and in every decision making. So probability helps us in what? In quantifying uncertainty. Okay. So if we are able to master this, then it means that you will be in a position to take decisions even under uncertain situations, right? So in this course, we will be teaching you how to assign likelihoods to events, how to characterize random variables. We will explain what random variables are, and so forth. So for example, if you are checking weather conditions, whether it rains or not, and so forth, we can actually characterize that as a random variable which takes values in whether it rains or not, right? So if it rains, you may give it a value, let's say 1. If it doesn't rain, 0, and so forth. So that's how we characterize random variables, but we will talk more about it later on. Then if we study events or random variables, then we will be in a position to give some, in a layman's term, a mathematical model for it, right? If we are able to get a mathematical model for it, then it helps us, what we call probability models, helps us to now compute the probability, the event that something happens, whether it is in health, if it's in agriculture, engineering, finance, what have you, and beyond. Okay, so these skills that we are going to get from this course will help us, be able to what? Apply standard statistical methodology in making decisions. And in this case, we are making decisions under what? Uncertain conditions. So we will entreat you to be punctual to your class. Make sure you attend classes, because attendance will contribute to your grading. Submission of assignments. If we give you assignments and the closing date, it should not go beyond 5 p.m. right? You have to be respectful in your engagement. We entreat you to switch your mobile phone off or put it on silence during lectures. Okay. Each week, as I said, you have 2-hour face-to-face and 1-hour tutorial sessions. We may put online resources on LMS, which is a Sakai platform. Exercises and interim assessment to be faced throughout the semester to help you consolidate your learning progressively. Okay, So we look forward to a productive semester with you. We entreat you to take this course serious, okay, especially those who go on with statistics, because these are the foundations that you need. Your level 100 courses, your level 200 courses. If you don't grasp it well, then you are going to have problems in your 300 and your final year. Okay, so please take note of this. You also have to take the opportunity to revise your 111 notes, so that because some of the things we will link it with the statistics aspect, so you don't have to throw that away. All right. Okay. So this course basically it's an elementary probability course. Okay. It doesn't mean that because you said it's elementary, then you take it as cheap and not learn. Okay, learn. Okay, because as I said, that's the basis, right? It will help us to know what basic probability is, what is random processes, and so forth, and the building blocks into this. Okay. So basically, probability is a measure of chance. Okay, that something, an outcome occur, right? So in this course, we are going to provide some systematic development of what the principles and methods of elementary probability theory. So we start our engagement first with what we call set theory and counting processes. You remember the sets you did in your SHS? That's the building blocks to probability. So we'll go over that again, and also talk about counting processes. How do you count? Okay, so for example, we all go when we move around, we see cars. Okay, if you look at the history of car numbering system in Ghana, we've changed it from from the before 90s. There used to be some a numbering system. Then in the 90s to 2000s, early 2000s, they have another licensing regime, and then they now change it. So now you can have a car that is, let's say, GR124, maybe 26. Okay, so it means that the first two digits are what? Letters. Okay, the next ones, or the first placement, I should say, placeholders, two of them are letters. Then you have maximum of 4 numbers plus maximum of 2 numbers, which is the year. Okay, now how do you count how many cars you can number using such a numbering system? Okay, that's the sort of things we do under counting processes. Okay, so after this we will talk about axiomatic foundations of probability. Okay, so we look at probability and its properties and so forth. Okay, what are the properties underlying this? Then we also talk about conditional probability, right? So we move you into the case where if something has happened, right? What is the probability that the other thing that depends on it will happen? Okay, so for example, some people may skip class. Okay, so I can say that if it rains, so that's a condition. Okay, if it rains, then I know that maybe a particular person in this class will not come to class. Okay, things like this are what we mean the conditioning. Okay, all right. Or so for example, or you go and test for malaria, right? Okay, if you are testing for malaria, you may, let's say we can talk about gender, so male or female, right? Okay, and some will test positive, others will test negative, right? Okay, and also if you look at it, you may have somebody who will even have malaria and test negative, and so forth. So we can use this principle to be able to compute the probability that, let's say, if we find somebody and the person is a female, what then is the probability that the person will test positive for a malaria, right? In such instances. So that will lead us to what we call Bayes theorem, which is also a conditional probability. That's one of the most important theorems in statistics, because it gives rise to another thinking, an area of thinking in statistics called Bayesian statistics, where you can actually incorporate expert judgment into what? Into data to help you make even decisions better. So that's why I said that whatever we are doing here is going to help you understand the statistics as in general, and especially probability. Okay. Once we are done with this, then we will move on to talk about discrete and continuous random variables and their properties and standard distribution. So we'll be talking about expectation, median, mode, and so forth. Remember in STAT112 we talk about mean, right? We were computing mean. In probability we will be calling that expectation. Median, we found median. We can be able to find that through the cumulative distribution functions and so forth. These are things you did in your SHS. But we will actually show you how this applies in terms of probability, and how do we link this to your STAT111 so that you actually understand the course. Okay. We are going to emphasize on theory and applications, okay, and we'll have examples drawn from production, marketing, engineering, health, agriculture, and the like. Okay. We expect some learning outcomes, not exhaustive because we can't list all of them, but essentially you should be able to define correctly and use core probability terminology like sample space, event, axioms, random variable, distribution functions, and so forth. Okay, this one from the Bloom taxonomy is just about knowledge, right? Okay, then comprehension. How do you distinguish between, let's say, discrete and continuous random variables, and interpret their either probability, mass, or density, and cumulative distribution functions? In learning outcome 3 will be applications. For example, how to apply counting techniques, permutation, combinations, and total probability rule Bayes theorem to solve multi-step probability problems. Okay. In terms of applications as well, how to identify and apply appropriate standard probability distributions, Bernoulli, binomial, and so forth. For the continuous distribution, we will just introduce you to it because you do it in STAT221 in your next semester as well. Then how to critically assess when distributional approximation, for example, Poisson approximation, binomial, and so are appropriate, and apply them correctly, right? So some indicators that we expect you to demonstrate will be true or correctly solve problems, accurate identification of distribution types, appropriate use of approximation techniques, and also coherent or written justification of methods chosen in assessment. Okay. So the course assessment plans is like this. So for exercises, I think we will do a maximum of 4. If we have more time, we do 5. Okay. So usually at the end of each section, we'll give you some exercises to do. That will constitute 10% plus your attendance, I should say. So we'll give some for attendance. Interim assessment, we'll do just 1, so I can take it off. And that should constitute 20%. In the 7th week, so I'm sure it will just be probability and conditional probability, so to speak. I think so. So let me conditional probabilities. Okay, but that will involve Bayes theorem as well. So let's take note of it. Okay. The final examination if we put them together, it should be 1 hour 30 minutes. So and that let's say 3 hours of examinations, right? But it usually will be two part. So you have 1 hour 30 minutes, sometimes 1 hour 45 minutes, and 1 hour in the other one. But so maximum it wouldn't go beyond 3 hours, all right? Written examination. So that will be one maybe on Sakai, and then the other part on extended problems where you do it in class, just like we had the last time. The grading scale is as per the University of Ghana, and you can check that from their handbook. Academic integrity, so it's central to the University of Ghana Academic Committee, community. You are required to uphold the principles of honesty, fairness, responsibility, respect, accountability in all academic way. So plagiarism in any form is a serious offense and is subject to sanctions stipulated in the University of Ghana undergraduate handbook. You should find yourself this to read. Okay. So also plagiarism, right, and so forth. And then the use of AI. There's a policy on AI. Please familiarize yourself with it and how you can use it to help you to learn. But if you use it to, let's say, do assignments, you have to disclose, okay, and so forth, so that we know what you have done. The idea is to understand the course, so that later on, if you are using AI to do anything, you know when it is wrong, you know what it is, and then you can correct it. We don't want the other way around, that the AI is now controlling you. Okay, that's not how to learn. It should be the other way around. Okay. There will be course lecturer evaluation, and for this, okay, even though we stated this one here, the academic quality assurance will do that, and I think it's 4 weeks before the final examinations, and that will be communicated to students and so forth. So please be on the lookout for. If you don't evaluate us, you will not even be able to see is it your results or something. So please take time and do so. It's also to help us to fine tune our teaching and so forth where we fall short. So be candid with your assessment and of your lectures. I mean, each one, when it is due to the period, tell us what you find interesting, what you find to be not so interesting, and where improvement will be. You think there should be improvement. That's also good for all of us. Okay, so the first week we are going to look at set theory, and the various things we'll do has been assigned over from 1.1 to 1.5. From there we move on to random experiments. We will continue to do random experiments to the next week. Then the basic concepts in probability, random variables, and so forth will follow from 4th week. Still random variables, okay, cumulative distribution, and so forth. Random variables computing using discrete random variables, probability mass function, and so forth. Modes, medians, and other location measures of distribution. So you see what we found out, what we did in 111 will now show up over here. Then we take expectation of random variables in more into more details, because that's one of the key things. From expectation, we will get variances and standard deviation, coefficient of variation, all of them. So you see what we did in the STAT112 will now appear here, but now in probability sense. Then from there we look at special discrete distributions, Bernoulli random variable, binomial random variable, examples and applications. In each of these, we will be looking at expectation, variance, and so forth, right? Then we look at geometric distribution, and then Poisson distribution. And then we do a quick introduction to uniform exponential, basically continuous distribution. So that will be the plan for the week. There will be revision week in the 12 week, covering all topics, past examination questions, and so forth. And then there will be end of semester examination. It doesn't mean it will be August 24th to 28th. Even though it will start from there, you have to check from the final exam timetable to get the where and when it will be written. The exercises, as I said, will be given to you. We'll do the interim assessment somewhere in the 7th, 8th week. The university will come out with a calendar for mid IAs, and then we follow suit. So usually it's a Saturday or a Sunday. Because there's a live class, we take it in the weekends. Okay. So teaching will be lectures, 2 hours face to face. Then there's also tutorial. There are online resources, I have said, case-based examples. So we'll give you some case studies, and then group problem solving as well. You must do the last one on your own, even if we do not give you. All right, you have to do so. Okay. Learner support plans. All facilitators or lecturers have their office hours. Please look at your lecturer's office hours. If you have issues, go to them. They will help you do it. On Sakai too, you can post your questions and discussions over there. The teaching assistants will also be there to help you. The teaching assistant also have rooms or offices in the department. You must make use of them. Okay, they are your first point of contact. When you do not understand something, go to them and make sure they attend to you. If not, if it's beyond them, then you get to the lecturers as well. Everybody is prepared to give you or help you. The supplementary tutorials may be arranged by the TAs, and if they do so, please make sure you attend, even if it's a Saturday or a Sunday. Okay, so resources for teaching and learning will be providing you with lecture slides or presentation, what we call BMA slides, because we do that from LaTeX and then we get the result. We will upload this on your Sakai for you to do. If we are weekly exercise sheets, we will give you weekly exercise sheets. Sometimes maybe with some suggested solutions, but it's appropriate that you work it yourself. So maybe you work it yourself, and then later on we get you some suggested solutions, right? There will be also some YouTube videos, so I'll be uploading some YouTube videos as well for you to, just like I've done this, for you to go through it. Past questions can be obtained from the libraries, other the departmental libraries. BAM library also keeps copies, and then you can do so. Okay, statistical tables. When we have time, we will also give you at the last and how to read normal tables. But these are things you do in your STAT 221 and STAT 223 and so forth. So we will just introduce you to it as in level 100. So supporting technologies, we may be using Microsoft Teams or Zoom if we are doing online study, YouTube as well for virtual office hours or occasional lectures if needed or if the need arises. Sakai will also show your course materials, assignment submissions sometimes, and grades. Okay, discussion forums too can also be found over there. Even with your peers, all right, they can so find the habit of or cultivate the habit of posting questions and so forth over there, so that there will be other interactions with most of the things that we are doing. You can use Excel as a start to do it. Those who are also ambitious can also use R, right, to do so. Okay, and so forth. So it's important that you start using it. The core of this, it's important that you get a textbook in every course that you do. Okay, read a textbook. That is to help you later on. You cannot do a course at the university and then you don't know a material or a textbook that goes with that course. I mean, later on in your interviews, especially those who want to do masters and so forth after your undergraduate, these are some questions that can be asked. Because if you have done a course and you don't know a particular author, so for example, you cannot do probability and at the undergraduate level and not know Sheldon Ross, right, and so forth. So those are some of the things you must take up as you move on. All right, and some of these things you can get them online, these books and so forth. Okay, so we can also, so there's a disclaimer that we can also make changes, but if we make changes, you see this on Sakai. All right, so that's it. That's it. So basically, that's your the course outline for STAT112. So this is just an introduction to it. All the lecturers will talk about it as well in the various classes. But this is to introduce you to it so that we know what we are up to the following as we meet from Monday onwards.